So in this short video, I want to talk to you about parallel vectors and parallel lines, right? So what is it that makes vectors parallel? And the idea is that two vectors are basically parallel if the directional vectors, so if the vectors themselves are proportional to one another. And so what that means is, it means that if you've got one vector that's, let's say, like A, B, C, and another vector that's like D, E, F, if you're going to say that those two vectors are parallel to one another, it means that A over D is the same as B over E, which is the same as C over F. So if they give you two vectors, they ask if they're parallel, it really just means that, putting the x coordinate over or x component over x component equals y over y equals z over z. And this should remind us a little bit like of the law of sines, which is the one other time that we've seen an equation that has sort of three parts. What it means is that in practice, when you do this, you're going to choose two parts. You're either going to put these two together, or these two, or the two outside ones together to actually work through an equation. So I have one little example here. Suppose you're asked to find the values of k and m so that these two vectors are parallel. To be honest, we should be able to do this without me going through it. So pause the video, try it on your own. If you don't get it, or if you want to, just watch what I do here. So this means that k over 3 has to be the same as 4 over 10, has to be the same as 7 over m minus 1. So if I want to solve for k, I'm going to pick two of these, and what I'm going to do is I'm going to choose these two here. Right? So doing that is going to get me k over 3 equals 4 over 10, which means 10k equals 12, just sort of multiplying across. This means k is 12 over 10, which means 6 over 5. So there's my value of k. Fantastic. To find m, well, this time I'm just going to choose these two. Right? I mean, if I wanted to, I could have chosen the first and the third, but that means I'd have to plug in my value of k, and I just don't really want to deal with that. So instead, I'll set the second two equal to one another. That gives me 4 over 10 equals 7 over m minus 1. Again, multiplying across again will get me 4m minus 4 equals 70. So 4m equals 74. M equals 74 over 4, which we can simplify to 37 over 2. And, neither of these answers is really nice, but whatever. The reality is we got the values of m so that the two vectors are parallel to one another, and that's what the question asked for. So here's another simple parallel question. This one's only in 2 dimensions, but the same rules apply. They should be proportional to one another. So pause the video and work this one out for yourself. So again, we know that 2x over 8 should equal 3 minus x over x. Again, I'll multiply across. This gives me 2x squared equals 24 minus 8x. Moving stuff together, 2x squared plus 8x minus 24 equals 0. We could divide out by 2 and end up with x squared plus 4x minus 12 equals 0. And when I factor this thing, I will end up with x plus 6 times x minus 2 equals 0. And so that gets me the answers x equals negative 6 and x equals 2. We're tempted to circle both of those, but in the beginning of the problem we were told that x had to be greater than 0, which means that 2 is the only answer that they want. To be honest, there's nothing wrong with 6 as an answer. There's nothing wrong with it, like in terms of, if we plugged it in, it would give you two parallel vectors. But because the problem asked for x to be greater than 0, this is the only answer that would actually be given on the exam. Okay. One more quick comment that I want to make in this video is just the concept of lines, and I think I wrote this as a typo earlier in the thing. Two lines will be parallel if their directional vectors are parallel. In other words, for lines to be parallel, the points that they pass through, the position vector of the points is not that important. In other words, when we write the whole r equals 1, 2 plus t times 3, negative 1, if someone's asking if lines are parallel, this part here doesn't matter very much. If they're asking if the lines are parallel, what they're really interested in is the directional vectors. Right? You want those two directional vectors to be parallel to one another or equal to one another, in other words, proportional to one another. So as an example, suppose you're asked to write the vector equation of a line passing through this point, which is parallel to this line. The idea is if the two lines are going to be parallel, then they have to have either the same directional vector or a parallel directional vector. So the easiest way to write this line is to just say that my parallel line will go through the point negative 1, 4, 7, and then we'll have a directional vector that is the same as the other one. The idea is that these two lines are parallel to one another because their directional vectors are not only proportional, they're actually the same as one another. These two lines have the same directional vector, they're just going through different points. And so that tells us that the lines are parallel. That's all I have in this video for. The next one is going to be about finding the angle between lines that are not parallel to one another.